All right, today we'll be looking at Chapter 7, Topic 8, Day 1. We'll be on this topic for 2 days. And this topic covers a special type of logarithm. Okay, it's a logarithm with a base of e. E is referred to as Euler's number. This symbol is referred to as Euler's number. All right, and it represents the natural log. E, the symbol E represents an irrational number, and it's equal to about 2.718281828459, etc. It's irrational, so it just goes on forever. It's the most commonly used and it's a very common and important value, and it's used in a lot of logarithm formulas. So we have a special logarithm for it with a base of this number. And this is referred to as the natural base. The inverse of the natural base exponential function is called the natural logarithm. Okay, it's a log with a base of e, and we represent that using ln. Ln represents the natural log. It represents a log with a base of e. So, for instance, if we look at example number 1, and we want to turn this into exponential form, well, this is a natural log, so it has a base of e, 4, and then it's equal to x. So if I wrote this as an exponent, it would be e to the x power is equal to 4. And of course, we could solve this if we wanted to, but we're not going to right now. All right, so just keep in mind, if you see a natural log, it's a log with a base of e, and e is equal to this number. Number 2, we have the natural log of 0.37 is equal to x. We want to change this to exponential. So the base is e of 0.37 is equal to x. So we would say e to the x power is equal to 0.37. This would be exponential form. All right, and let's practice changing this into logarithmic form. We have e to the x is equal to 8. So if I wanted to turn this into logarithmic form, I have e to the x equals 8. So for logarithmic, it would be a log with a base of e of 8 equals x, but a log with a base of e is the natural log. So it's natural log of 8 equals x. And this would be the logarithmic form. Number 2, e to the 5 is equal to x. So e to the 5th power is equal to x. So as a logarithm, it would be a log with a base of e. So natural log of x is equal to 5. And the number 3, we want to write this in logarithmic form. So we have e to the 3rd power is equal to x plus 9. So we would turn this into a log, so it's a log with a base of e. So the natural log of x plus 9 is equal to 3. We can also use the properties of logarithms for a natural log. Okay, so we can use the properties, the quotient, product, and power properties with a natural log as well. So for instance, we have 3 times the natural log of 10 minus the natural log of x. Well, remember, if we have a coefficient on the outside, it can just become the exponent. So this is the natural log of 10 cubed minus the natural log of x. And now I can combine these because it's minus. So I can combine this into a single one, 10 cubed divided by x. And now it's a single logarithm. And the reason I'm dividing is because I'm subtracting these two logarithms. Okay, so it's subtraction. Number 2, I have natural log of 40 plus 2 times the natural log of 1/2 plus the natural log of x. First, let me work on this one. So this natural log of 40 plus natural log of 1/2 squared, okay, because that can become the exponent. So I can 1/2 squared plus the natural log of x. That's natural log of 40 plus the natural log of 1/4 plus the natural log of x. Now I can combine these into a single logarithm because they're all being added, which means when I combine them, it can be multiplication. 40 times 1/4 times x. 40 times 1/4 is 10 times x, so that's the natural log of 10x. So we can also use these properties that we learned earlier on a natural log. All right, the assignment is on the screen.